In the standard real number system, the repeating decimal 0.999, trailing off forever, is exactly equal to the whole number 1. If you reject that conclusion, you aren't alone. To a human brain built to perceive physical distances, the idea that these two are the same feels like a mistake. The intuitive argument is that point 0.9 repeating is merely the number just before 1. It seems to creep infinitely closer, adding digit after digit, without ever quite arriving. If that sense of a near miss is correct, there must be a tangible mathematical gap between 0.9 repeating and 1. We are going to treat this as an investigation. Using the tools of arithmetic and geometry, we are going to hunt for that specific missing space. If that gap exists, then our system of real numbers is logically inconsistent. But if we can't find it, it means our internal sense of distance is failing us. Start with the fraction 1/3. Most accept its decimal is 0.3 repeating. Triple that, and we get 0.9 repeating. But 3 times 1/3 is 3/3, exactly 1. The two sides must remain equal. Set x to 0.9 repeating. Multiply by 10 to get 9.9 repeating. Subtract the original x. The infinite 9's cancel out, leaving 9x equals 9. Divide by 9 and x is exactly 1. Our basic tools prove the gap is 0, yet the mind still resists. We still want to see a physical space between the numbers. Subtracting 0.9 repeating from 1, we expect an endless cascade of zeros with a single 1 at the end. But an infinite sequence has no end. There is no final decimal place where that 1 could sit. An endless string of zeros is not almost 0, it is 0. We can also search for the gap geometrically, using the density property of real numbers. A density property says between two distinct numbers, you can find another by taking the average, like 0.95 between 0.9 and 1. But finding a number between 0.9 repeating and 1, it doesn't exist. Because there is no space for an intermediate number, there is no gap. The two labels represent the exact same location in space. It turns out that the urge to find a gap isn't entirely unfounded. There is an advanced system called hyper-real numbers, where mathematicians allow for infinitesimals, numbers that are infinitely small but still greater than 0. In this alternate system, the tiny difference between 0.9 repeating and 1 is labeled as h. While this gap exists in that specialized framework, in the standard number system we use to measure our world, that difference is 0. Much of our confusion comes from viewing 0.9 repeating as a growing process, as if the number is still running toward a destination. In mathematics, an infinite sequence is not an action, it is a finished value. It doesn't approach 1, it is 1. Numbers are abstract concepts that can wear different outfits. Just as 1/2 and 50% describe the same value, 0.9 repeating and 1.0 are just two different ways to write the same thing. Trusting mathematical definitions over our own finite perception allows us to navigate concepts that our intuition simply wasn't built to handle.